This is part of a series, and the series goes like this. We did one already on solder, and then Neil has already held a practical session on soldering. Practice, actually doing it, getting the tools in your hand and seeing what's good and what's bad and using the tools and so on. This is a presentation on through-hole soldering. And there's another couple still to do, one on SMT, surface mount technology soldering, and one on desoldering and rework, how to get things off of boards and how to repair and replace and stuff like that. So, through hole, what does through hole mean? Through hole soldering is soldering where the components go through a hole. You have a board and it has copper on it. The board is typically Paxlin board, Vero board, or FRG4, the fiberglass board, and there's a thin layer of copper on it. Copper comes in 1 ounce, 2 ounce, and 4 ounce thicknesses, which is ounces of copper per square metre of board. What we do is, using the soldering iron, we put a small amount of solder onto the area that we're about to solder to. This is called tinning. And at this point, I introduce, see that little ball of solder on the tip of the iron? That's essential. If you take an iron which has got a point, basically, it's either got a single point because it's conical, or it's got a fine line because it's chisel shaped, and try to get heat through that into a piece of copper, it will not happen. There will be very, very little heat transfer from a clean iron onto a piece of metal. So what you have to do is keep a tiny wee ball of solder on the tip of the iron, and that ball of solder's job is to provide a volume through which heat can flow from the iron to the substance that's being soldered. So you always need to have that little bit of solder. That's really important. So having tinned the board, we also tin the component, and there's a mythical component that I've put there, and you'll notice that I've tinned the leg of the component, which means I've put my iron against it and put a little bit of solder on it so that the leg of the component is tinned. And at that point, I add heat from the iron and I add a little bit of extra solder. And that's how soldering takes place. And when I remove the iron, I'm left with that kind of shape of mound of solder round about the component leg. And at that point, I crop the leg off just above that little triangular mound. Now that's the easy one. That's what we call single-sided soldering. Very often boards, in fact, very difficult to buy a single-sided board these days. If you're buying them from China, they nearly always come double-sided. And the trouble with a double-sided board is you have copper on both sides of the board, and you also have copper down through the hole itself. In the through hole, it's called a via, or a plated through hole, a PTH. And if you've got a plated through hole, then everything is exactly the same as before, except one, you need to add a little bit extra solder, because as you can see, capillary action is going to take solder down through the hole to the other side. So it's going to put more solder into the joint before you get a decent joint. And secondly, it's going to take a little bit longer in time because there's more solder. It takes longer to get it melted, get it flowed, to take it away. Once you've been doing it for, I don't know, half an hour, it becomes second nature. It becomes part of that flow, mindfulness thing that you can do all day without any trouble. So here's the technique in summary. Use the iron to heat both the part and the pad. Add solder. Don't carry solder on the iron. You have a tiny touch, just the wetting of the iron to make sure heat can flow from it. You then add solder to the part and the pad. You continue heating till you get that nice shape, and then you let it cool off, and you don't blow on it. I talked about blowing on it earlier, and it's one of the things that people do. They're holding it close to their fingers. They think, oh, that's hot, that's hot. I'll just blow on it. You don't blow on it under any circumstances. And once you've done it, there's what you should be looking at. The little volcano is perfect. If you've got a ball like that, you've put too much solder in, use your solder sucker to take it out. If you can see some of the pad or you can see gaps, you've got not enough solder. If you've got a ball that's not flowed fully onto the pad, that's a cold joint. If you overheat it, you may destroy the pad, you may burn the board. It might look fine, but you've done damage to the board. And the last one to keep an eye out for is shorts. Always use enough solder, but not too much, so that you make sure that it doesn't connect over to the next pad across. And at that point, it's flim show time. Right? Now this good looking fella's taking this little job that he's doing. He's put a little bit of blue tack on the back, and he's going to push it into position. This is all done in my microscope, by the way. So he's now pushed it into position, and you'll see the blue tack start to emerge underneath it as he squeezes it down. There we go. And then the iron will come in from the right, solder will come in from the left, a little bit of solder on the iron to get the heat flowing. There we go, heat going in, a little bit of solder onto the iron, and then solder onto the job, so the job takes the solder, not the iron. Wait for a second, take it away. And away we go, same trick, a little bit of solder into the iron to get it to work. Solder onto the job and let it go. You can, once you get into the habit of this, you can do it all afternoon. Now, because he's a really good teacher, this fella, wait till he gets to the fifth one, he'll have put a little bit insufficient solder in. Watch this. So, wee bit, not enough solder. Needs more solder, that. So he brings it back, gives it a little more heat, a little more solder, and he's done. So, I kind of breeze through that part of it because we've all done it. I'll not say we're all experts at it, but we're all well aware of it. And what I'm intending to talk about today are some of the other tools and techniques that we should be thinking about if we're soldering. You have to hold the job steady. The number of times that you see people chasing a bit of vertiboard round about their bench with a soldering iron is fascinating. You should be able to see what you're doing. Things have to be clean. Cleanliness is next to godliness, at least in the Reverend Ian Paisley's Irish Dictionary. You need to tin both sides, you heat it, you join it, you put a little bit of extra solder in. Don't underheat it or it doesn't work. Don't overheat it or you damage something. And don't blow on it. And lastly, and I've said this before and I'll probably say it again, I'll be saying it to the day I die, you do not carry solder in the iron. The number of people that put a blob of solder on the tip of the iron and then take it and expect to wipe it onto a piece of wire or onto a resistor, that's never going to work for you. Give that up. Find another thing to do. So, holding the job steady. There's the easiest one, blue tack. I've always got a big blob of blue tack handy for sticking things down, for holding things to boards, for holding boards to the bench, for holding things onto the board while I solder them, or a rubber band's good as well. There's a great big bulldog clip, and that's holding that board onto an enamel baking tray. I'll talk about the baking trays later on as well. There's a cheap and easy one. Pair of pliers with a rubber band round the handle. So the rubber band holds the pliers closed and the pliers hold the board steady. And the board's now up at a slight angle off the bench so you can get access to it and you can get things flush. There's a great big weight and a bit of metal. The bit of metal happens to be the back panel off a PC and the weight happens to be a chuck off a drill press. I've got a spare chuck from my drill press and I use that sometimes just as a weight. There's a subtle one. If you look carefully at that board, you'll see that at the top left and the bottom right, there's two little links of wire. You know the normal enamel wire that you use for making links when you're using a prototyping board. And I've used two little links there to catch the corners of the board. And that way, my breadboard becomes the vise for holding the PCB steady. If you've used any of these breadboards, you'll know that mostly they've got a big rubber pad right across the back, so they stick superbly to surfaces and they make quite a good wee vise. Talking about rubber bands, there's one there. That's the easiest way to hold it down. That rubber band is holding that board to the base of a microscope. We'll talk about microscopes in a wee while. And there's a pillow of blue tack. We'll talk about that when we come to do the surface mount soldering. But that pillow of blue tack I use constantly. If I'm connecting stuff to a surface mount board, then I'll bring all the surface mount parts out and just gently put them onto the blue tack. The blue tack stops them blowing away when you sneeze or cough and keeps them there where you can pick them up. But it's not sufficiently sticky that you've got to find tweezers and peel them out. You can just pick them up very, very easily. A pillar of blue tack's a really good thing to have on the base of your microscope. More conventional ways of holding the job steady. There's a vise, a wee bench vise. Again, the vise has got a couple of jaws that are I've got a triangular and angled insert that will hold the printed circuit board. That vise also holds a thing called a pana vise. Now, a pana vise is what gets used in industry when they're making up printed circuit boards. It's, as you can see, it'll take a Eurocard quite happily and it'll turn over, flip over from one side up to the other side up. So you put it there, you can put all your components in through it, and then you flip it over and do all the soldering, flip it back. Those cost money. I happen to have one, but I don't think it's a thing I'd put on my shopping list. There's a picture of the detail of it. As you can see, the captive edges are always that triangular shape because that way it holds the board steady. If it's a flat shape, then the board can move up and down. So that triangular thing lets them do that. You'll also see another couple of triangular notches out at the right-hand side there, which will let you put the board in vertically. If you wanted to put a board in vertically, do work on it, turn it over, do it the other way, that'll let you do that also. We had a number of these, it must be about a decade ago, that we got a cheap deal on. They were about £4 each at the time. I took one and then subsequently gave it away to somebody that didn't manage to get one. They now cost about £12, I think, from CPC. I tend to not use it, that's why I gave it away. And the reason that I don't particularly like it is because the board is about 6 inches off the ground, which I find a bit high for my tastes. And the stability wasn't the greatest either. But it's perfectly adequate. Now at this point, I'm kind of going to reiterate something that I've said a number of times before, but it needs saying that one of the beauties of having this group is that if there's something that you're interested in, you can try it before you buy it, if you see what I mean. So these things for holding it steady, if you think, I'd like a look at that, I'd like to compare that with that, let us know and we'll bring them to the 65 Club, we'll bring them to Elderslie and we'll give you a play with it. I've done this with crimping tools, with soldering tools, with all sorts of things. If you see something here and you think, oh, I'm interested in that, but I don't want to be putting money down and getting something that goes in the drawer and never gets used, let us know and we'll arrange to give you a play with it. Here's a case in point. I bought these. These are stick vices and they're wonderful things. They are designed to hold printed circuits and you can see they hold them about, I don't know, half an inch off the deck. The wing nut there holds that bit steady and then the other bit's on springs and it moves in and out. And having played with them and used them for a wee while, I thought And that's easy enough. There's not an awful lot of technology in that. So that's my version of it. And that's two 3D printed jaws, couple of rubber bands doing the job of the springs, and that's a lollipop stick sticking out the back to keep it all together. And I've given, I think, 3 of these away now. So there's lots of ways of holding things steady. And now that you're holding things steady, you have to see what you're doing. How do we see what we're doing? Let's start looking at lights. Again, I'm preaching to the choir here, so don't excuse me if I go kind of quickly. Daylight is the best light at any point, and if you can do your work, if you've got a wee sun trap at the back of the house that you can do it in, that's absolutely ideal. Overhead lights, yep. Angle poise lamps. A number of us have these angle poise lamps with a lens and a light on it. They're good. You can get daylight lights now, and that's a LED light where the LED is matched to daylight in terms of frequency, so that's less wearing in your eyes. I'm also a huge fan of the headlamp. The headlamp, you use them in camping and hiking and all that good stuff. Goes round about your head on an elastic band and has a lamp at the front that you can do that with. The beauty of the headlamp is it points where you're looking. As you look round about for things, the headlamp moves with you, so it's always illuminating what you're trying to see. Whereas if you've got a light to one side, it's playing on one thing and you're over to the other side looking for something and you're not getting the benefit of the light. If you're going to buy a headlamp, you need to have one that will come down. Some of them just point straight ahead, which is great if you're on a bicycle or you're walking. But if you're wanting to read or you're wanting to work with something in front of your face, then you need a headlamp that you can pull down where you can actually angle it down the way. And they don't all do that. So if you're thinking of buying a headlamp, look into that and make sure that it'll cant down. And lastly, desk lamps or reading lamps. There are thousands of these. Go and look at the IKEA page. They've got 250 of them. And even if the 250 don't include the one that you want, they'll give you the ideas. Do you want it on a gooseneck? Do you want it on an angle poise? Do you want it hanging from a string? Do you want it hanging from a chain? Do you want it static? You know, there's all sorts of ways of manipulating them. There's an expensive one. That's a daylight LED angle poise. That covers half the things I just talked about. There's the angle poise mechanism, and there's a big light, daylight balanced, ideal thing, but 108's a lot of money. And there's some of the headlamps from £4 or £5. £8.99 there buys you 2 of them. You can get them in the pound shop for a couple of pounds. You can get them from Ali, you can get them from Banggood. I just went there to give me a typical top end price. Don't expect to spend much more than about a tenner on a headlamp. So, having got lights out the way, loops. I think they're gem loops. They are of use, but of limited use. They're great for seeing up close, like the top left image there. If you want to look closely at a detail, then this will do that for you. Don't expect to work with one of these because it has to be held right up to your eye, and then the job has to be held right up close to the loop. And if you do that, within 5 minutes, you'll get to smell the chicken, and you don't really need to be doing that. There's my headlight there, look. And these other loops are jeweller's loops, and they similarly have a focusing range that's about an inch ahead of the loop. There's RS will sell you a packet of 3 9 times loops. That's loops that have 9 times magnification on them. Or the other ones are, I think, 2 times. Now that wee one that's got, in fact, it lives here, it lives on my desk. That's how often I I use that. This is a 9 times loop, and it's got a piece of wire soldered round about it, and then the piece of wire leads off to a croc clip, and that croc clip clips on to the leg of my glasses when I'm working, and that way I've got direct vision through the top of my glasses. I've got reading vision through the bottom half of my glasses. These are varifocal specs that I wear. And I've also got this wee intense ×9 loop up here. So if I'm working on something and I need to know what that is, I can pick it up and just look up to the left and see what it is, put it down, and I'm back in my normal vision. And that kind of loop is really, really useful for that. And I recommend it to you. I have also in my career come across these boys. These are the types of loops that surgeons or dentists use. And they have advantages and disadvantages. Obviously, they either go on instead of glasses or they go on over the top of your glasses like that. The problem is surgeons and dentists tend to be working at arm's length. A dentist doesn't want to be in close to your face with his face while he's working. So the dentist tends to be at arm's length. And these are focused so that what they focus on is 2 foot, 2.5 foot in front of you. And that's not necessarily a comfortable way of working. If you're sitting at a bench working on a model or working on a printed circuit board, you really want something that's only a foot ahead of you, because that tends to be the range that you work at. So these are available, they cost money, and to my mind, they're not necessarily a good idea. So let's look at other vision aids. You've all seen this, using a second pair of glasses over the top of your glasses. That guy's a watchmaker on the repair shop, and he does that for fine stuff all the time. This is used in crafting. The Y shape at the bottom has 2 little rubber feet that rest on your chest, just about the sternum. The thing hangs out and there's a loop that goes round about your neck. So it keeps the lens about 8 inches in front of your face. It's for needlework, cross-stitching, crocheting, stuff like that. And there's also a wee ultra-high magnification bit close to where it's touching your chest for very, very high magnification. I have used this. It doesn't suit the way I work, but it doesn't mean it might not be useful. You can get that from any of the craft shops, from Hobbycraft or wherever. You can also get one from Amazon or the Bead Shop in Glasgow. I think that's where I got mine from. Useful, worth trying. This is what I was saying a wee while ago. It's worth, if you fancy some of these, let us know. We'll bring them along and give you a go, and you can say, no, I couldn't work like that, or I could work like that, that suits me. And that way you don't have to waste money buying these things to get putting them in a drawer. Talking about putting them in the drawer, you'll see these things. It's a headband with a visor that you clip lenses into. And the lens goes from ×2, ×3, ×4. Mine's is in a drawer because I'm not allowed to use it anymore. It was actually quite useful, but the problem is that I'm sitting there using it. The dog came up to say hello. I looked round about to say hello to the dog. The dog looked up and saw a great big eye and get the fright of its life and ran away through the house. And I've been told I'm not allowed to put that on again anymore because I frightened the pets with it. So, but again, it's useful. If you want to play with it, let me know and we'll let you see it. A couple of further options here. It's very difficult to see in that picture, but I've got a little plastic stand for my mobile phone that holds it at an angle. And when the little plastic stand's holding the mobile phone at an angle, if you go to the right side of that image, there's a magnifier app. It costs you £1 to download it, and you can zoom in on your phone, and your phone becomes a sort of digital microscope for looking through, and you can see gives you a good magnification, certainly big enough to work with. The other option to the left is from our friends in China, and it cost me a couple of pounds just for the shigs one day. I thought, well, try more daft enough. It's a set of three lenses, a wide angle lens, a telephoto lens, and a macro lens, and they all go into this little clip, and then the clip goes over your phone, so the lens gets clipped in place in front of the lens of the mobile phone. These lenses are not the most... Carl Zeiss will not be looking to steal photo copyright things on these lenses. They're a bit pants. However, they do work. As you can see, there's a bit of distortion there. But we'll come back to those lenses in just a few seconds, because it turns out that those lenses have got another use. And the other use is this. That's a stand, and you can see the job on it. And then sticking out for the stand, there's a white plastic 3D printed thing that I made. And inside that is a webcam, like we're all using at the minute. And the webcam gives you a nice picture of the job, but it's not big enough. So one of those lenses from that set that I just talked about got glued to a little bit of printed circuit board. And the printed circuit board also got a couple of LEDs put on it. So tucked up under the front of that webcam is one of those lenses plus a couple of LEDs. And that is the microscope that I tend to use. Picture of my desk, and you'll see there's the microscope right in the centre there. And below it, you'll see the little board that I'm working on, a little green board. The webcam signal goes back to a computer, and the computer displays it. And you can see the display up above the green board, full size. Now, the software that's displaying it is the software for the visualizer. Remember, we used the visualizer for demonstrations. It's a wee webcam on an arm. You can use the visualizer if you have one, but this is as good as the visualizer, and the visualizer software comes for free. You just download it, and you can use it for any webcam, including this camera that I just made, or this one here. Now, that little video that I showed you earlier was from 2017. 2017 was the first time I did a soldering presentation up at the Scout Hall. And when I did this, there was a stampede. Everybody that saw this said, "Oh," I called this a dash cam microscope because I was looking for dash cams at the time when I found it. And I put it up, and everybody that saw it came and had a play with it and wanted it. It's a wonderful little tool. However, that was nearly 10 years ago. Mine's, that one, is 4 inches across. Now, they've cottoned on to the fact that an awful lot of people want these. So I went to one manufacturer's website and had a look, and he's currently got 22 different soldering microscopes. And they go from 3 inches to about, I think it's 20 inches. And they've got lights, they've got clamps, they've got different types. There's all sorts of ways you can do it. That cost me about £25 all those years ago, and I still use it. Although I have to say, I don't often use it like that. I tend to do the trick of plugging a USB cable into it. And when you plug a USB cable into it, the video you can then look at on the visualizer software. And so I can use that as the microscope, but I can have the picture on the screen. The beauty of having the picture on the screen is that your eyes are rested. If you have a screen that's a long distance in front of you, your eyeballs are sitting looking parallel. If you've got a little screen close to you, your eyes have to swivel in to look at the screen, and you get eye fatigue. The muscles round about your eyes get fatigued, you get tired, you need a rest. Using the big screen is like watching television. You can just sit there and do it for hours and hours and hours. But these things are wonderful. Before there was these things, there was microscopes, and that's a really old one. You can tell it's old because it's got the two things for your eyes, the two eyepieces, but it doesn't have a third one with a camera on it. If you try to buy a microscope these days, it'll have two eyepieces and it'll have a camera mounted on it, because nearly everybody takes the camera output and puts it to a big screen for all the reasons that I was just explaining. And so you can buy a microscope. The reason that we used microscopes back in the day was if you tried to use a video camera, they weren't quick. The technology that was used in the cameras, you were getting an image every 25th of a second, which was a bit of latency, and you found yourself moving something underneath the microscope and it wasn't moving immediately. It was catch up. Whereas nowadays, the latency is so low, you get 100 hertz out of these microscopes, so it's like real time, so you don't need an optical microscope. There are optical microscopes there. They cost a lot of money. If anybody wants one, I've got one going spare, that one there, because basically I never use it. So, on to the main tools, the soldering iron. You get soldering irons with power ratings from 12 watts to 80 watts. You might want a mains iron. You might want an iron that will run off batteries. You might want an iron that will run off USB, including off a USB power bank. A USB power bank will solder all afternoon for you. This matters quite a bit in model railways because you might have to solder droppers at a far end of the layout where there is no electricity to plug in a soldering iron. Or you may have to solder something under the board where it's not convenient to have a mains socket. So a battery or a USB iron might be something to look at. Talking about the power, the 12 watts to 80 watts matters in two places. I'll explain that to you in a minute. Your iron might be a smart iron, a dumb iron, or there's a nearly smart iron, and I'll explain all three of those as we go. For me, the most important part of a soldering iron is tip to grip. If you're holding a soldering iron in your hand and it's comfortable, I like the grip, the tip of the iron to be no more than an inch away from where I'm holding it. To my mind, it's the difference between using a pencil and using a paintbrush. If you've got a paintbrush and you're holding it 6 inches away from where the paint is, it will work, it'll do what it's supposed to do, but you won't get the finesse. If you're holding a pen, you can do very, very detailed work down close to where your hand is. So for my mind, tip to grip is really, really important. And if I'm choosing a soldering iron, the thing that I will pick before I look at anything else will be tip to grip. Tip width I'll talk about as well, and whether you can get replacement tips and whether you can get tips that suit you. There's a couple of specialist tips that we use in desoldering, and not all the irons have those tips available. So that might be something else we'll talk about. And then the tip type, you get pointed tips, you get chisel tips, you get tips that are straight, and you get tips that are rounded. Now I actually quite like the bent tips because with the combination of holding the soldering iron like a pen and being under the microscope, that way the bent tip goes down and touches the board, and I find it easier to do the three. If you're looking at a screen, you're only seeing one image. You don't get a stereoscopic image, so you don't have depth perception. And I find that having a bent tip means that I don't really need depth perception because the bend in the tip covers the distance for me. It needs to be able to do 180-ish to 350 degrees or you won't be able to solder. And if you get a soldering iron that doesn't allow you to solder, then you need to have a serious look at your life choices. You need to fuel it, as I say, could be mains electricity, could be a battery, could be a USB. If you've seen me with a soldering iron down at the 65 Club, I use a big remote control battery. It's a big blue thing. It's 21 volts and it lasts for 6 months of occasional soldering jobs and occasional power supply jobs. And I charged it this week, so I won't charge it again till July probably, the big blue battery. Or USB, either USB off your bench, USB off your computer, or USB off of a power bank. You can also get gas irons. Now, I know one or two people here use gas irons, particularly for track work. Track work, you've got to get a lot of heat into a lot of metal, particularly if it's a bigger gauge, and a gas iron is relevant for that. But I wouldn't use a gas iron for electronics. I have one, and I used to use it for part of my sins in a previous life. I used to be at sea, and I'd go up masts to fix antennas and stuff like that. And it's 2 o'clock in the morning, it's dark, and it's raining, and you're up the top of a mast. You don't have time to run a cable, and you don't want to run a cable, so you take a gas-powered soldering iron. I'll give you a picture of one in a wee minute, and we'll talk about how they work. Before I go on, though, there's one thing we have to talk about, and that's tip earthing. The tip of your iron may or may not be earthed, and if it is earthed, it may be earthed in one of two ways, and you have to think about that. So I'll be talking about that very specifically. I talk a lot about earthing in these talks. I noticed that half the oscilloscope talks seem to be about earthing, but that's just the way it is. Now, if you're going to buy one of these things, I will tell you about Antex, I will tell you about Weller, I will tell you about JBC, I will tell you about Hako. But in reality, you're going to go to China for it. I know you're going to go to China for it, and you know you're going to go to China for it. But let's go through the motions anyway. Talked about dumb irons. There's a dumb iron. That's an Antex. Now, by dumb, what I mean is this. There's a coil of nickel chromium wire in the heating element of that iron. And when you put electricity into it, it heats up. And the hotter it gets, the higher its resistance becomes. And the higher its resistance becomes, the less electricity it allows through. So it sort of balances out. It ends up evening out at a particular temperature. And that particular temperature will maybe be 260 degrees or 280 degrees or whatever. But there's no turning it up to give you more heat for a job. There's no turning it down so it doesn't burn out while it's sitting, not doing anything. It just sits at that temperature all day. Doesn't make it a bad iron. The Antex irons I'm a huge fan of. I've got two of them, I think. One of them is an old thing that you can't buy anymore, and I love it dearly. But that's the standard Antex iron that you buy now. They used to cost about 15 quid. They now cost about 30 quid. I suspect that if you went to Argos or someplace, you could probably get it cheaper than that. It comes in 12 watts, 15 watts, 18 watts, and 25 watts sizes. And it also comes in a 12-volt version. Now, if you're doing automotive type work, if you're underneath the bonnet of a car regularly, that might be interesting. If you're using 12 volts on your layout, that might be interesting. But £45, a bit of money for a 12-volt dumb soldering iron. There's a smart iron. And basically what we have here is the iron over to the right has got a thermistor in it to measure the temperature, and it's got a heating element in it to set the temperature. And then the little box of tricks over to the left with the 345 on it is the solder station, and it measures the temperature at the tip and adjusts the power going to the iron to keep it at whatever temperature you've set. So I can set a temperature on that iron and it'll stay there. That one again is mine and it's ancient. It's got to be 30 years old, that. You can no longer buy the Weller WSL. You'll pick one up on eBay probably, but I don't know how much you'll pay for it. If you go and buy the modern one, there it's there. The modern one is made by Weller, obviously. £117, including the stand, including the iron, isn't actually a bad price. The next of our suppliers is JBC. Now, I didn't know if JBC was American or European or what they were. I tried to look it up. They're one of these multinational things. They've got offices in America and an office in Barcelona and offices in Japan and China and Australia. I think they're an American company. £460 for that. But I'm putting that up for a reason. You notice where it says T210, also known as the T210 soldering station, right? That will come back in a wee minute. And lastly, of the brands that I put up, here's Hako. Now, Hako are a Japanese company and they are very highly thought of, and I don't think they do much else apart from soldering equipment. Those of you that have seen my little tool for measuring soldering iron temperatures, that's a Hako instrument. Came from these guys, again, 20 or 30 years ago. I've never used Hako equipment. I've never had any of it. To me, there's something a bit Fisher-Price about it. All that yellow and blue plastic, but that's just my personal prejudices coming to the top. Now, I come back to this. The JBC 210, brilliant iron, brilliant solder station, sells a shed load. And if something like that is really, really good and sells a shed load, you'll never guess what our friends in China do with it. This came up on my feed about 18 months ago, and I thought, for 40 quid, that's worth buying. It wasn't actually this one, it was very like it. It was that controller, that handle, a different soldering stand, but it also included 3 other bits. So I got 4 bits and it came to £39.99 at the time. So I thought for less than £40, that's worth a punt. It says it's T210 compatible, and basically it is. It uses the same bits as the T210, the JBC T210, but it's their controller. And I bought it, played with it, and it's a wonderful piece of kit. Really, really useful. When you take the iron out the stand, and the time it takes you to move the iron from the stand to the job, it has went from being cold to being 350 degrees, and you can solder with it and just put it down, and over the next 5 minutes it cools. And when you pick it up again, it's hot again by the time you get to the job. Wonderful thing. So I bought that and I took it to the 65 Club to demonstrate it to people, to give people a play with it and let them see it. And I think 3 or 4 of them at the 65 took a wee note of it and went away to, where do you get it and whereabouts is it? And they took the notes and away they went, and that was fine. The 65 Club meeting was when Davy Dick was in Australia. So it wasn't January of this year, it was January of last year, because Davy wasn't there. And when he came back, I told him about it. Now, there's mine. Look at the tip to grip on that. It's the width of a pound coin. Right, it's about 25 millimetres. There's the wee soldering station. It's a rotary encoder for setting everything. And that's a wee stand. Has got the brass shavings in it. It's got a wee corner for all those little bits of scrap solder and scrap metal, and it's got a sponge. It's got a whole lot going on there. So I told Davy about it, and he was interested. So he went away and ordered one. But the one that he ordered was the T115. And the T115 is also a JBC iron, and you get T115 bits, and they cost the earth as well. And this is the one that he got, and there's his, and it's even tiddlier than mine. It's even tinier. It's about 2/3 the size of the one that I bought. Now, these are designed for people fixing mobile phones, doing iPhone repairs and stuff like that. You actually get a little rubber mat with it to put on your desk to stop the iPhone from marking your desk or your desk from marking the iPhone. And it's a very, very fine tip, but it is a brilliant wee soldering iron. And the money that it costs is nothing, given that, you're doing this for a hobby, you're using a soldering iron all the time. 40 quid's not an awful lot of money. 30 quid's even less. This is the TS100. This has been about now for about 8 years. It'll take either a battery input from the big blue battery or USB input from a USB source to drive the soldering iron. And it's got its own range of tips, but they're compatible with some American standard. I don't know what they are. The tip to grip isn't just as good as some of the others, but the controller is all built into the handle there. You can see it just above where the person's holding it. You can see that it says 300C. And that's a really good, fine soldering iron for work on like Vero board or printed circuit boards. Ideal. It's got a big brother called the TS80. And the TS80 was replaced by the TS80P. And the TS80P is just a bit bigger and a bit chunkier, and it's ideal for droppers, for soldering to track, for if you're putting together brass models, a TS80 would be absolutely fine for that. And so those are all smart soldering irons. Moving on, semi-dumb. This was the standard soldering iron in industry and in education for decades. It was called a magnestat iron, and that's what I call semi-dumb. The iron itself has a permanent magnet in the shaft. And the thing about permanent magnets is they get to a certain temperature and they stop being a magnet. And when this one stops being a magnet, it drops out. It drops out, switches off. And as it switches off, the coil goes off and it cools down. As it cools down, the magnet becomes a magnet again. And as the magnet becomes a magnet again, it pulls in. And as it pulls in, that switches the power back on, which causes the heating up to take place. And so there's a wee feedback loop. And if you've got one of these, it's sitting on your bench and it ticks. It goes as the magnet goes in and out and in and out. And there's typically a neon light on it that goes on and off and on and off as the magnestat clicks in and out. And you can still buy them, I've discovered. And there's a whole class of people that do repairs to old television sets and old radios and radiograms and stuff. And they like to use new old stock of capacitors and resistors, and they like to use original tools like magnestat irons and Avo voltmeters and stuff like that. There's the gas soldering iron. Now, the gas soldering iron, you would think that what happens there is you light the gas and the gas heats the tip. It doesn't. What happens is you light a piece in close to see where the plastic stops and the metal of the tip starts over to the left there. There's a tube in there and it's full of wire, catalytic wire. and you light that, the gas coming through reacts with that wire, and that reaction gives off heat, and that heat is at the right temperature for soldering with. If you just burn the gas would go up to 1,000 degrees and everything would drop to bits on you. Whereas with this, you heat this catalytic wire, the catalytic wire heats the tip, and that takes the tip up to about 300 degrees, and you can solder with it. As I say, useful if you're out in the garden soldering, garden layouts, anyone? If you're up a mast soldering, if you're underneath the track, underneath the board, and you're nowhere near a source of electricity, then that might be useful to you. So we're nearly done. A couple of things I want to talk about. Power. This is a picture from somebody else's video, and he's comparing a Hakko soldering iron and a Weller soldering iron. And what he's doing is he's soldering straight to copper. There are twice, when the power of your soldering iron matters. Firstly, when you first switch it on, power is energy per second. Let's say it takes 400 joules to heat up your soldering iron. A 20-watt iron will take 20 seconds to develop 400 joules in the iron, whereas an 80-watt soldering iron will take 5 seconds to get that same number of joules to the iron. So the time it takes the iron to heat up is directly proportional to the power. And the other time it matters is in situations like this, where the heat is getting sucked out of the iron. Can the iron give enough heat to keep the temperature up? If you put a soldering iron tip onto solder on a piece of copper like that, then what will happen is the copper will act as a heat sink and it'll suck the heat away. And as the heat gets drawn away, it's up to the iron to replace that heat to keep the solder liquid. And you need a high power iron if you're going to do that. Now the thing is, nowadays you don't often need to do that. If you look at a modern printed circuit board, particularly one that's been designed in the last couple of decades, you'll find these things. There's a great big earth plane there, and that pin has got, see those 4 wee wires that go from the pin to the earth plane? Those are called thermals. And you'll also notice that that SMD capacitor over to the right, the top end of that capacitor has got thermals on it as well. And what they do is they give you an area where you can solder, but the metal plane isn't there. It's electrically connected to the plane, but it's not thermally connected to the plane, so that you can solder that very easily with a cheap 12-watt iron. Will solder those quite happily. Whereas if you put a 12-watt iron onto a metal plane like that and tried to melt solder, it would laugh at you. It just wouldn't happen. I've mentioned tip to grip. There's the Antex, and that's about 4 inches nearly tip to grip. There's my little Weller, that's about 1.5 inches tip to grip. There's the TS100, 2.5 inches tip to grip. As I say, there's that one, the 210, brilliant instrument, about 1 inch tip to grip. And Davies is even less, it's about, I don't know, 18 millimeters tip to grip. Looking at the tip width, if it's too narrow, heat won't flow out of it. Remember I said that you've got this job, you've got an iron and you've got whatever you're heating, and you have to get heat from one to the other. The wider the iron is, the more the area is, the more heat flow you will get. The narrower it is, the less heat flow. So what you want to do is tune that. If it's too narrow, you won't get heat out of it. You know, the heat won't flow from the iron. If it's too wide, you're liable to wipe solder onto the track next door. You think about a piece of Veriboard. In fact, you won't have to think about a piece of Veriboard. I'm about to show you a piece of Veriboard. So for that reason, what I do is I match the tip width of the iron that I'm using to the typical track width. So, I say there's the weather that I use. It's got a 1.2, 1.4 millimetre track. Vero board, those holes are 2.4 millimetres apart, and those tracks are 1.8 millimetres wide. So just under 1.8 millimetres, to my mind, is good. There's my other Weller iron, and it's got a 2 millimetre tip, and you can see where that's starting to overflow the board. It would be heating either side of the track, but also I'm liable to heat the tracks on either side, which is okay if there's nothing on them, but they might be populated, they might have something there. There might be a wire in that track, and if I heat it, the wire pops off. So for that reason, I don't want to go too wide. And there it is with the big 3.2 tip, and you can see by that time I'm definitely heating the track next door. There's an Antex, it's got a 1.2. That little Antex iron for 30 quid starts to look like a bit of a bargain. It's the right sort of tip width, the right sort of power. There's the TS100 2.4. Now the TS100 comes with about a dozen different tips, so you can pick the tip to do what you want. There's the 210, and I worked out the company that sells the 210 is called OSS Team. If you're looking for one of those, that's what to Google. Google OSS Team T210. And there's a 1 millimetre tip, and as you can see, that's starting to be just a wee bit narrow. If I put that into that solder, the solder will melt, but it'll melt up the middle and then round the sides. It'll not be the best melt. And the wee one, the 115, that's got a point tip on it. As you can see, I can actually put that soldering iron down through the hole and solder something in the next level down. Right, that's how thin that soldering iron is. It's frightening. Now I'm going to talk about earthing again before I finish. If you're liable to be working on something that has electricity in it, then you don't necessarily want your soldering iron to be earthed. If the tip of your soldering iron is connected to the mains earth and you touch something that's got electricity in it, then you can cause a short circuit. And okay, that can be dangerous. There's all sorts of health and safety reasons why you shouldn't do that. But just on the practical reason, you're liable to blow a fuse or fuse a track or cause damage to whatever it is you're working on. So there's that. If you are working on something that isn't connected but has sensitive electronics on it, MOS, for example, CMOS, and you have an iron that isn't earthed, then you can get static build-up on the iron, either from static build-up off your clothes and through you, through the carpet that you're standing on, the seat that you're sitting on, or if it's a mains iron from residual electricity passing through between the heating element and the tip. So for that reason, if you're working on something that's MOS sensitive, you might need to earth the iron. And there's an in-between setting whereby you earth the iron through a resistor. If you ever see these things, the earth straps for connecting yourself to the workbench, those don't go your wrist to the click straight to the earth of the mains. They go your wrist to the click on the workbench to a 1 megohm resistor to the mains. That way, if you come into contact with static electricity, it will leak gently a few microamps or a few nanoamps through you down. So some situations you maybe want a resistor between your soldering iron and the earth. So there's a TS100, and if you look carefully at the bottom on the left-hand picture, you'll see the bit that I have blown up on the right-hand picture, and it's a wee earth symbol and a wee screw. And what that is you can unscrew that and either put a wire on it to an earth, or put a resistor in it to a wire to earth, or more likely put a wire on it and then put a resistor, put a click so that you can click it onto the bench so that it's earthed the same way as you are when you're working at your workbench. Yep. I'm not giving you advice on what to do here because it depends exactly on what you are doing. I can't give advice on whether you're going to be using something that's on. I very often work on equipment that's on, so I'll factor that in when I'm thinking about what I'm doing. Same as I factor in scope probes when I'm working on equipment that's live. I also work on stuff that's static sensitive. All the pick chips are static sensitive. You've got to have your wits about you when you're working modern pick chips. So it's down to you to do what's best for the job that you're doing. There's my Weller. Before I go any further, look at that, a dual soldering iron stand, so you can have two soldering irons on at the same time. That cost a tenner for CPC. Holders for two irons, plus the wee brass thing, plus a sponge for about a tenner for CPC. Don't say I don't get you bargains. If you look at the Weller soldering station, and again, I'm going to zoom in, it's got a little hole in the bottom that takes a 3.5mm jack, and that's the earthing arrangement for that. If you take the jack out, then you know how these jacks, you use them in audio equipment. When the jack's out, you can hear the speaker, and the switch shuts and connects the speaker to the amplifier. But when you put the jack in, it disconnects the speaker and connects the output to your headset or your headphones. Well, this is exactly the same thing. When the jack is out, the earth is connected through to the soldering iron. When the jack is in, the earth goes through the jack and back in to the soldering iron. So I can either put a short circuit on that jack, in which case it's as well being out as being in because it's still short. I can leave the jack out, in which case it's earthed. I can put the jack in with nothing connected to the jack, just an open and empty jack, and that's an open circuit, and I can now use MOS, or I can put a 1 meg resistor between the two poles of the jack, and that way when the jack's plugged in, I've got a 1 meg safety resistor on the earth of my soldering iron, right? If you're using a JBC, an Antex, what do you call the Fisher Price ones, Haco? If you're using one of those, they'll have some sort of arrangement like that on it. The little ones that we were just talking about that came from China, the 210s and the T210s and the T115s, have got an earth point on the back, and it's a 4mm jack plug. So again, you can do what you need to do with a 4mm jack and a piece of cable, but you should always think about earthing the job that you're doing. You've got an earth in your hand. Do you want to be touching things with it? So there's 2 or 3 other things I want to talk about just before we finish. The flat enamelled baking tray, the silicon mat, fume extraction, stands, I've already mentioned it, spool stands and tools. I'm going to leave soldering iron stands, solder spool stands, soldering tools, heat sinks, all that stuff, because we don't have time and you guys already know most of this stuff. A flat enamel baking tray is a great thing for soldering on. There's one for Robert Dias, £8. There's another one from Amazon, set of 2 for £12. The idea of these in the oven is that they're perfectly flat. You put cookies on them, and there's a little lip at the back so that when you pull it out the oven, the lip makes sure that the cookie doesn't get left in the oven. Right? I use it on the bench the other way around about. I solder on it, that way I can splash solder to my heart's content. The boss will not be giving me grief for having solder on the table. And if I have to pick myself up and go away, I can just pick the enamel tray up with the job and the resistors and the capacitors and that bit of solder and all the stuff that the whole lot's on a 1 foot square job. I can pick the job up and move it away, put another job down. If I have to leave something half done, I've got it nearly finished, but those connectors haven't come in yet from China, so I can leave the job on a baking tray, put it to one side. The other thing is that wee lip, if you have that wee lip round the other way so that it's at your side of the job, then when you drop surface mount devices and they skitter off towards you, they don't skitter off the edge of the table and down into the deep pile carpet. They skitter as far as that wee lip and stop. And they saves you losing parts and losing wee bits that drop off the table. Silicon mats have become very, very, very popular recently. It's a blue silicon rubber thing. Some of them have magnets in the corner to hold. These are designed specifically again for people that are fixing mobile phones. And they're incredibly useful for any type of electronics work, particularly soldering. You'll get them in lots of little boxes that you can keep screws and nuts and bolts in, or for holding screwdrivers and holding tools and stuff. I suspect that what you want to do is go and have a look. You can see the prices, £1.28, £1.40, £2.50, delivered for China. They're not dear. Extraction. Now, extraction's an interesting thing. If you go and buy an extraction system, then what you generally get is a fan and a filter. And it takes the air out your room through the filter and then puts it back into the room. And nearly all, this is the CPC page. I went to CPC and looked up fume extractors, 24 products found, and they're all the same. So if you're sitting in a room and you're working away, you're soldering, then this thing's soaking the smoke, the excess flux and stuff away from you through a carbon filter, and then the air gets back into the room. Now, the stuff that doesn't get caught by the filter, therefore, comes back into the room. So I was watching a TV programme a couple of years ago. We had a bit of a laugh about it on here. It's these guys fixing retro radiograms and television sets and pinball machines and stuff. But one of the things that I did see that I thought, oh, I like that idea, is he's got an X-Pellier fume extractor for a toilet on his bench. The X-Pellier sits there soaking all the air from where he's working. And because it's a mains extractor fan, it's more powerful than the wee 12-volt ones that you get from CPC. But instead of just putting it through a filter and back into the room, he's got it going through that flexible hose to the window where it disappears and is never seen again. And to my mind, that makes a much more sensible idea than trying to use charcoal filters to try and capture that stuff. That stuff, by the way, if you don't filter it, you're using it all the time, it causes tremendous headaches. Hence the expression flux sake. You've all heard it when you've been working. I've heard you all use it more than once. Anyway, I've done as much damage as I think I need to do today. So if there's any questions or any thoughts, then now's the time.